Hello guys, you're welcome back to my channel Fun with Physics. In this lesson, we are going to consider models of electric circuits. That means at the end of the lesson, you should be able to describe how electron flow in a circuit using a simple model of your choice, or maybe any one you can think of apart from the one we used in this lesson. Okay, now it is important to know that no single model can actually explain any system, and it's important to know that models are actually used to describe things that we cannot actually handle, like the solar system. For instance, you want to describe how it works, you can handle it, so you use model, a simple illustration, to describe how it actually works. Or maybe you want to describe how electron flow in a circuit, something you cannot see, but you can simply use a simple model to explain or to describe how it actually flew and what it does. Okay, so no single model can explain everything in a system. It's important to know that. So for the sake of this lesson, we have three models that we are going to look at. The first one is a rope model. In the rope model, we have two boys, sometimes more if you want. Okay, one of the boy or one of the guy will hold the rope firmly while the other one pulls and push. Pulls with the left hand and push with the other hand, so that the rope can keep going round and round. Okay, let's assume this guy is the one that pulls the rope and push the rope. Okay, now because he's the one that gives the rope a push, we are going to regard him as the cell. We are going to take him as a cell. He is actually representing the cell. That is what the cell does. The cell actually pushes the electron through the circuit. Now the rope moves round and round, right? So the rope represents the charge flowing. Okay, the charge flowing round and round the circuit. Right? Now this guy that actually grips the rope without doing anything but gripping it represents a component, let's say a bulb. Okay, now if this guy pulls the rope very, very fast, because of friction, the guy gripping the rope may feel a warm sensation in his hand, isn't it? So that's the energy from the rope, energy from the charge. Okay, that warm sensation that he feels is actually the energy, represents the energy given off by the charge to his hand. Okay, but when he pulls it slowly, he may not feel the warm sensation, may not be that much, so it means the charge is not flowing too fast. That means it's not giving as much energy to the component, that is to this guy's hand. Okay, now what this implies is that when the charge is very, very fast, when you have a battery that has much more potential difference or much more voltage, the charge will move very, very fast. It will push it very, very fast through the circuit, and more energy will be supplied because you have more charge flowing in a given time. Okay, but if you have, like, let's say a cell that doesn't have much voltage, it's not going to push the charge as fast as the other one. Okay, so when this guy has exhausted his energy, cannot pull and push anymore, it means the battery is down or the battery is flat. Okay, so did we see how we've used the boy, the two boys, the rope, and all of that to represent what's actually happening in the circuit? Okay, let's look at the water model. In the water model, we have a pump that pumps water through a tap and through a narrow pipe, and then through a meter to measure the flow rate, and back to the pump. Okay. Now in the water model, what do you think is representing the cell or the battery? Of course, the pump, because that is what pushes the liquid, right? The water through the pipe. Now, what do you think is representing the wire? Of course, the pipe. What do you think is representing the charge? The water. And the tap is actually the key or the switch. So when it's on, water flows, but when it's off, no water flow. The narrow pipe is representing the resistance, or where you have a component. Of course, what component does is they provide a certain amount of resistance to the flow of charge. So it's narrow here, showing that there's a resistance to the flow of charge. Okay, just like this guy gripping this is providing a certain amount of resistance. So when you have two persons gripping, it means you have twice as much resistance as what you have. Okay, the same thing applies to this narrow pipe. Okay, the narrower the pipe, the more the resistance to the flow. Okay, so it means it's representing the circuit component. While the meter here is representing the ammeter, the item, the instrument that measures the flow of current. Are we good? Right, so when this pump is actually locked, cannot pump any further anymore, it means the battery is flat. Okay, now let's look at the factory model. That's a simple illustration of the factory model. It's a little bit complicated illustration. Now we have a factory, we have a truck, the delivery truck, a shop, and back, and the road. Okay, so look at the analog below. What represents the charge? What do you think represents the charge? And what represents the voltage? The factory, of course, represents the voltage, and the truck represents the charge. When the truck is full, it means it's carrying enough energy, a lot of energy, from the factory to the shop. Okay, the truck gets to deposit the stuff, the items produced in the factory, in the shop. It means this implies that the charge deposits the energy to the circuit component. So the shop here is actually representing a circuit component. Okay, so the truck moves empty back to the factory to collect more charge. Okay, to collect more energy. So you can see that the charge keeps flowing, but once the energy is deposited here, it leaves empty back to the factory where it picks more energy. So by the time the stuff in the factory here has been exhausted, it means the battery is flat, isn't it? So once you exhaust your stuff, the items in the factory here, it means the battery is flat. Guys, you can demonstrate your own model with a suite. For instance, you can have like say 5 suites, and then you move around and pass the suite to someone, to some other person that can, eat it. You are representing the charge. Where you pick the sweet from is representing the battery. And the guy chewing the sweet represents the circuit component that uses the energy. Okay? By the time you've exhausted your sweet, it means the battery is flat. Okay? Now you notice that each time you go around and give the sweet, you always come back with an empty sweet, with an empty without any sweet at all. You always return back to pick a new sweet. So that's exactly what happens with the charge. When they deposit the energy, they return back to pick another one. Okay, now we can look at this. It's a good demonstration of what's happening here. Mr. Q carry the energy or the voltage from the battery, moves around and deposits the energy at the bulb there so that it can light up, and then Mr. P go return back to pick new energy from the battery. Can you see it? So the cycle continue on and on like that until you've exhausted, you've run down the battery. Okay, All right, guys, if you have any question concerning this lesson, please drop your comments in the comment section, and don't forget to like this video, and don't forget to subscribe. Have a nice day.